Hi friends, this is Arun and I am back with another video on development of lateral surface. Uh, Here we'll be dealing with an example of a prism. Now this particular prism is a pentagonal prism, and the pentagonal prism is cut by section plane. Now the speciality of this section plane is that it is inclined to the axis and perpendicular to VP. It is cutting the top face edges as well as the base edges. Okay, so the previous problems that we have seen, either the section planes would be cutting few of the vertical edges or the slant edges for pyramids, vertical edges for prisms. It may be cutting all of them or a few of them, but here, along with the vertical edges, the section plane is cutting the edges of the top face as well as the edges of the base. So how to draw the development of this kind of a problem is what we will be seeing today. So let us start with the problem statement. So here you have a pentagonal prism of 30 mm base side and height 50 mm, which lies with its base on HP such that one of its rectangular faces is inclined at 40 degrees to VP. It is cut to the shape of a truncated prism with the truncated surface inclined at 30 degrees to the axis so as to pass through a point 30 mm above the base. Develop the truncated portion of the prism so as to produce a one-piece development. So this is a statement and this is the solution. So we'll see how to get this particular solution. The first thing that you need to understand is what is this pentagonal prism and how is this section plane cutting it. So that can be seen in the next slide. So this is what is the pentagonal prism and this is how the section plane is cutting it. So what you can see here, we have a pentagonal prism which is cut by a section plane. Section plane is shown by the red color and the truncated portion of the pentagonal prism is shown by the yellow color. All these hidden lines are the edges of the base or the top face and even the vertical edges. So this may not be very clear, but I think this would be clear. Now this red is the section plane and you can see that it is cutting the pentagonal prism at the top face, at the base, and also it may be cutting a few of the vertical edges. So this is a combination of intersection points with the top face, with the base, and with the vertical edges. So now what you need to understand is this particular problem. How many intersection points do you get? So this particular section plane, when it cuts the pentagonal prism, you want the lower portion, that is the truncated portion. So this is the lower portion or the truncated portion. The development of lateral surface has to be drawn for the lower portion. So as you can see, there are 6 intersection points: 1, 2, 3, 4, 5 and 6. So these are the 6 places or the 6 points where the cutting plane or the section plane is cutting the physical edges, either the edges of the top face or the edges of the base or the vertical edges. Okay, so let us see one by one. So you can see here the section plane is cutting the base edge AB at this point. So this point is marked as intersection point number 1. Okay, next the section plane is cutting the vertical edge BB1 at this point. So this point is marked as the intersection point number 2. Okay, it is some distance above B, like this, some distance above B. Similarly, 1 is some distance between A and B, that is the base edge. You can see A here and B here, so it is between A to B, intersection point number 1. Similarly, the section plane is cutting the top or the top edge, that is B1 C1, somewhere in between B1 and C1. So you can see this is the intersection point number 3. So somewhere here, this is the intersection point number 3 between B1 and C1. So you can see 3 is some distance from C1. So this is the third intersection point. Now here you find the fourth intersection point. The cutting plane or section plane is cutting the top face edge D1 E1 at this point. So this point is 4. It is at some distance from D1. So you can see 4 is some distance from D1. Similarly, 5. 5 is the intersection point of the section plane with the vertical edge E1E. You can see somewhere here. So that point is 5. E1E, the vertical edge. And finally, 6 intersection point. So it will be somewhere here between A and E. So it is some distance from E. This is the point, and this point is 6 at some distance from E. So these are the 6 intersection points. So what you observe is 2 intersection points, intersection point 1 and 6 are with the edges of the base. To be specific, AE and AB, the 2 edges of the base. Then the next 2 intersection point 2 and 5 are with the vertical edges BB1 and EE1. Okay, and the next 2 intersection points are with the edges of the top face. They are D1 C1 and D1 E1 here. Okay, so this is the location of the intersection points. So in the front view, this is how you're going to see the intersection points. 1 into bracket 6, because in the front view, as you can see here, 1 is seen, 6 is not seen because 6 is behind 1. Next is intersection point 2. Next is 5, and finally 3 into bracket 4 for the top face edge. So 3 is in front, as you can see, and 4 is behind. So 3 into bracket 4. So this is the front view of the intersection points, and also the front view of the truncated portion of the prism. So I hope this portion is clear. Next we move on to the actual solution. So this is the front and top view of the pentagonal prism. Now if you see by the statement, you have a prism of 30 mm base side and height 50 mm. So the base edge of the pentagonal prism is 30 and the height of the prism is 50. Now this pentagonal prism is lying on HP on its base such that one of its rectangular faces is inclined at 40 degrees to VP. So one of the rectangular faces, that is either this AB, BC, CD, D or E1. So in this case AE, this is the rectangular face which is at an angle of 40 degrees to VP. You can incline any edge for that matter, but we have taken A1A EE1. So A1A EE1, this rectangular face is inclined at 40 degrees to VP in the top view. So that is what you are seeing here. This is the top view of the pentagon. The center of the pentagon is O1. O is the center of the top face, which is ABCDE, which consists of corners ABCDE. sorry, A1, B1, C1, D1, E1, and O1 is the center of the base, which consists of the corners A, B, C, D, E. So now this is about the location of the uh, top view, that is the top pentagon at 40 degrees to VP. Now in the front view, what you find is the axis height of the prism is 50 mm. So you have to project all these corners of the base and top face onto the front view and extend them up to 50 mm in height. Also the axis, and then name the corners of the top face as A1, B1, C1, D1, E1. Name the corners of the base as A, B, C, D. And what you find is in the front view you are seeing three rectangular faces, which are A1, A, B, B1, B, B1, C, C1, and C, C1, D1, D. So three rectangular faces are seen in the front view. Two rectangular faces are behind, they won't be seen. That is why you find that E1E is not seen. E1E is a vertical edge which is behind these rectangular faces, so they are not seen. Whereas the remaining four vertical edges, that is A1A, B1B, C1C, and D1D, are seen in the front view. Only E1E is not seen. So this is the front and top view. It is same as the first step of projection of solids. So the same thing you have to draw here as first step for development of lateral surface. Now once you have done this, next comes the location of the section plane. Now section plane, you can see it is cut to the shape of a truncated prism with a truncated surface. So here the truncated surface is nothing but the section plane, inclined at 30 degrees to the axis. Okay. So if it is inclined at 30 degrees to the axis, that means the inclination to XY line is 60 degrees. And it passes through a point on it 30 mm above the base. So 30 mm above the base, the section plane is passing through. So you have to first mark 30 mm over the base along the axis, a point, and at this point you have to draw the section plane at an angle of 30 degrees to the axis or 60 degrees to XY line. So we'll do that. So you can see the cutting plane or the section plane, 30 mm from the base, inclined at 30 degrees, and this 30 mm from the base is along the axis. 30 degree inclination is to the axis, or it is inclined at 60 degrees to the XY line. So this is the section plane. And now the section plane, as we had seen, is cutting or intersecting the edges of the base, then a couple of vertical edges, and the edges of the top base, as can be seen in the front view. Now you identify these intersection points and number them. So these are the intersection points. So you can see here intersection with the edges of the base, then intersection with the vertical edges, and intersection with the edges of the top face. Name them. So as you can see here, 1, 2, 3, 4, 5, and 6. So 1 is the intersection with with the edges of the base AB here. So this is 1, and that can be seen here, 1. Then next is 2 is the intersection with the vertical edge B1B, that is 2. So you can see here 2, and then 3 is the intersection with the edges of the top face D1 C1. So here that is 3. 4 is also the intersection of the section plane with the edge of the top face, that is E1 D1. So that is 4. So 4. So 4 is in bracket because 4 is behind 3 and it won't be seen. And 5 is the intersection point of the section plane with the lateral edge E1. And finally 6 is the intersection point of the section plane with the edge of the base AE here. So AE. So mark all these intersection points. So there are 6 intersection points. 2 with the base edge, 2 with the vertical edge, and 2 with the edges of the top face. So totally 6 intersection points. Now, as per the development of lateral surface, you need to find out the true length of these intersection points either in the front or the top view, because we need these true lengths to be drawn in the development of the lateral surface. So now, as can be seen in the front view, only the intersection point 2 and 5 are lying on the vertical edge. Now you can see the length of the vertical edge is 50. So this 50, that is B1B and E1E. These are the two vertical edges which are intersected by the section plane. So you get 2 and 5 intersection points. So these are the only 2 intersection points lying on the true length of the lateral or the vertical edges. So they can be directly projected onto the development of lateral surface. But the problem is with 1, 6, 3 and 4. Now if you observe, this 1 and 6 are lying on the edges of the base, and 3 and 4 are lying on the edges of the top face. So none of these are in their true length in the front view. Okay, so what we need to do is we need to project these intersection points onto the true length of these top face edges or the base edges. Now you will be getting the true length of the top face and the base edges only in the top view. Okay, so you need to project this 1, 6 and 3, 4 onto the top view and get the true length of the intersection point from these respective edges. So we'll do that. So I have done that. I projected 1, 6 onto the top view and 3, 4 onto the top view. So now you need to mark these intersection points in the top view. So we know that 1 is between A and B. So this point is 1. So you can mark that. And 2 is between, 6 is between A and E. And 3 is between B and C in the top face, and 4 is between D and E for the top face. So you can mark all those intersection points and number them. So you can see 1 is between A and B, 6 is between A and E. This is for the base. And the top face 3 is between B1 and C1, and 4 is between D1 and D1, that is for the base. And that is what you can see here also. 1, 6, 3 and 4. So you have located these intersection points on the true length of the top face edges and base edges. Now all you need to do is find out the length or the distance of these intersection points from the one of the corners of the either the top face edges, either top face corners or the base corners. So what we find is 1 is at a distance of 18.29 from A. Then 3 is at a distance of 5.52 from C. 4 is at a distance of 15.02 from B. And 6 is at a distance of 8.94 from B. Now these distances will help you to locate these intersection points on the full development of the Pentagonal Prism. So now we need not be bothered about 2 and 5 as I said, because 2 and 5 are on the true length of the vertical axis. Okay. So that being done, I think we need to find out these lengths also, or directly we can project them. Fine, that is also okay. Fine. The next step is we need to draw the full development of the pentagonal prism. So if you cut upon this pentagonal prism at say A1, the vertical edge A1, and if you open it up, then you get a rectangle of 150, 30 into 5, 150 by 50. So that rectangle I have already drawn here. So I'll directly take it to save the time. Yes. So this is the full development of the pentagonal prism. So 150, so 30 into 5, 150 by 50, 50 mm is the height. So this is the full development of the pentagonal prism. And as you can see, the vertical edges are A1, BB1, CC1, DD1, EE1. And since we started with A1, we are ending with A1. Okay. So now our job is to draw the projection lines and to transfer these 6 intersection points onto the development of the pentagonal prism. So we'll draw the projection lines, thin lines from 2 from 5, only these two, because only 2 and 5 we are getting the true length in the front view. So I just need two projections for one for 2 and one for 5. So I'll locate these two intersection points first. So I'll go for point of a different color, let us say red color, and a different type of point. I'll locate the intersection point 2. Now as you can see, 2 is the intersection with the vertical edge BB1. So where is BB1? BB1 is here and 2 is here. So they are intersecting at this point. So this point is the intersection point 2. Now 5 is the intersection with E1. You can say E1. So 5 with EE1. So this is the intersection. So I got two intersection points. I'll name them. So this is 2 and this is 5. Similarly, I will locate 1, 3, 1, 3, 4 and 6. So first I'll start with 1. So 1 I'll be finding at a distance of 18.29 mm from A, and it is between A and B. Now this AB is the edge of the base. So we are talking about this edge AB somewhere here. So I'll locate the point randomly somewhere here. Okay, and I'll ensure that this point is at a distance of 18.29 mm. So from here to here, this distance is 18.29 18.29. Okay, so this point is 1. Okay, similarly I'll locate 6, because 6 is the intersection with the base edge AE. So I got AE here, base edge, and 6 is at a distance of 8.94 from A. So I'll locate a point closer to A here on AE, and this point is at a distance of 8.94 from A. So I can see here it's 8.37. I'll change it to 8.94. Yes. So this point is intersection point number 6. Okay. So 1 and 6 are taken care of. Now we're left with 3 and 4, that is the intersection with the edges of the top face. Now, 3 is the intersection with the top face edge B1C1. So this is B1C1, and the distance of 3 is 5.52 from C1. So I'll locate C somewhere here, and I will find out the distance. It should be 5.52. Yes, and this is 3. Similarly, I'll locate 4 intersection point, the last intersection point 4. 4 is on the top face edge BE, that is B1E1, and it is 15.02 from B. So I'll locate it somewhere here. It is at a distance of 15.02 from D, and this is the intersection point number 4. So I have located all these intersection points. Now I need to join them by straight lines. So as you can see, all these intersection points are joined by straight lines, indicating the section plane. So I'll join them, and I'll be developing the lower portion, the truncated portion of the prism. So join these by thick lines so as to distinguish between the upper and the lower portion. So I'll use a thick line. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Okay, and 6 back to 1. So this is the truncated portion, and since all these portions of the vertical edges, that is 2 to B is also the remaining portion of the vertical edge BB1, that has to be darkened. Then C1 to C is a vertical edge that has to be darkened. D1 to D is a vertical edge that has to be darkened, and this 5 to E is the portion of the vertical edge E1E, so that also has to be darkened. So this darkened portion is the development of the truncated portion of the pentagonal prism. So if you take a piece of paper and if you cut it to this particular shape, and if you fold it and join, then this is the shape that you get of the truncated prism. So I hope this process of locating the intersection points for the top face, the base, and the vertical edges was clear for this pentagonal prism. So please practice this problem, and I'll be back with another video on developments. So till then, take care. Bye.